Hey everybody, thanks for being with us today. We're going to get started here. It's just about 1 o'clock. This is our second webinar of 2026. My name is Jenny Novak and I'm the marketing manager. I coordinate the webinars here at Dyne Fire Protection Labs. Welcome back if you've joined us for webinars in the past. And thank you for joining us if it's your first Dyne webinar. We have a great turnout today, so thanks for being here. Just a quick intro about us. Dyne's an independent testing laboratory that's been testing firefighting foam for over 25 years now. We also test antifreeze, dry chemical agents, and sprinklers. We have some exciting news. We have been working in R&D, and we're going to be adding some testing services this year, including corrosion admit, diesel fuel, and water mist nozzles. So stay tuned for more news on that. Watch the website, our newsletter. We'll be coming out with that information shortly. In 2024, we were acquired by NFPA Global Solutions, and we've continued to provide the same fast, reliable service and quality test results that everybody keeps coming back for. We're always active for certified or accredited. Dyne is ISO 9001 certified and also has a 17025 accreditation by A2LA for our automatic field sprinkler testing. Just a little housekeeping before we get started. If you have any questions during the presentation, you can go ahead and type them into the either Q&A panel or the chat screen. We usually save them up for a Q&A session at the end, but it's nice to kind of have those rolling in so we can get started as soon as the content is over. Stay until the end of the webinar to receive a certificate of attendance today. People ask about those. A lot of people use them for, I've heard, NISA credits. We are NISA partner in learning. This webinar is also being recorded, and you will receive a link to that recording. We also publish it on the Dyne YouTube channel, and that'll go out after the webinar sometime, probably tomorrow. Today we have something new for you. We've done the NFPA firefighting foam testing webinar before, but this year it's going to be presented by Ben Quick, who is our lab manager at Dyne and oversees the lab staff in the testing labs here. Now I'd like to turn it over to Ben to talk to us about testing.
Thank you, Jenny. I do appreciate the introduction. Very excited to be here with everybody today, and I'm excited to share this information. So we will just dive right on in here. All right. A little bit about me. Here I am, Ben Quick. I'm the lab manager here at Dyne Fire Protection Labs. I have been here with Dyne almost 4 years now. Just an important note right before we get going, any opinion expressed here in this presentation is the opinion of the author, myself, and does not necessarily represent the official position of NFPA or the technical committees. All right. So first things first, why bother testing your foam concentrates? A visual inspection of the foam alone is not enough to determine the foam quality. These foam systems can be installed years ago. They can be laying dormant for as long as they need to, but when you want to turn those on, excuse me, you sure hope they work. So to analyze the quality of that foam, you can't just take a look at it and say good, bad, pass, fail. You do have to get it into the lab for some actual quality testing work being done. Who is telling you to do that? That comes directly from NFPA 25, the standard for the inspection, testing, and maintenance of water-based fire protection systems. Chapter 11 specifies that foam concentrate testing shall be conducted annually. To do that, foam samples of foam concentrates shall be sent to a manufacturer or an approved lab for quality condition testing. What is an approved laboratory? NFPA doesn't necessarily define or credit labs or give that certification out. Ultimately, it becomes, is the report acceptable to your authority having jurisdiction? They make the final call on what is or isn't a approved laboratory, if they will approve the results on our test results. I will say we've never had any issues with any AHJs not accepting these results, and have been accepted as a wide and far an approved laboratory for this type of testing. How do we test foam quality? What does that mean? Once again, NFPA does not necessarily in the standard define the term foam quality, but the industry at large has sort of landed on these two measurements as a general evaluation of the quality of the foam. That would be the expansion ratio and the 25% drain time there. So your expansion ratio, that basically is a measure of how well does your foam up, so to speak. Is it expanding, forming a nice foam blanket over the source of the fire or whatever you may be fighting, and is that effective at combating the fire? Now, we typically, for low expansion foams, see an expansion ratios between 5 to 1, 10 to 1, usually around 7 is a pretty healthy benchmark. Different foams have different expansion types. High expansion foams, obviously, you're going to see a higher ratio. That expansion ratio is going to be closer to 1,000 to 1, 2,000 to 1. The second measurement we're taking a look at here is the drain time. The 25% drain time. If your foam forms up, great. You have a nice blanket. That's fantastic. If it quickly and almost immediately dissolves back into a liquid, that's going to affect the ability of the foam to fight that fire. So we do measure that 25% drain time. It's just a measurement of how quickly the foam returns to a liquid state after it's been discharged. Those are the two real benchmarks that determine, yes, this foam is of acceptable quality and will work in an emergency situation, versus no, the foam has degraded to a point that it is no longer effective and should be likely replaced. So those are our two main testing, the expansion ratio and the 25% drain time, but it is far from all the testing that is done in the laboratory. Those are what we call the performance metrics. Here, these are more of the physical properties of the foam that we are measuring in the lab as well. Those tests include the refractive index, the density of the foam, viscosity when applicable, the pH of the foam, is it acidic, is it basic, and as well as the film formation and the spreading coefficient on applicable foam types. In this case, AFFF foams, AR-AFFF, something that's inherently film forming. We take these measurements just to compare. We like to compare that, compare that information to manufacturer specifications when known, and that can give us a more complete picture of the health of the foam. We may see signs of dilution with a lowered refractive index or density. Maybe water has leaked into the system or has contaminated the foam concentrate in some way and is diluting prior to proportioning and use, in which case you will see a decrease in efficacy of the proportioning. You won't be able to proportion at that nominal rate, and your foam will be inherently less effective at fighting the fire. Viscosity as well, that's a huge measure for us in terms of measuring the alcohol resistance of AR-AFFF foam. The viscosity comes from these polymers in the foam that give it that kind of viscous gel-like state. When we see foams that are supposed to be viscous and they are coming back at a more watery, lowered viscosity, closer to that thin water-like substance, that indicates to us that there's possible loss of alcohol resistance. Concerning for AR-AFFF type foams, and certainly can impact the ability of the foam to fight those fires. pH, same thing there. We're looking to see acidic or basic. Has the foam taken on qualities that maybe are leading to faster degradation as it sits in whatever tank it may be sitting in, or whatever the system allows? As it ages, natural degradation will occur. We just want to make sure it's not happening to a point of no efficacy. Finally, when we come to the film formation, spreading coefficient measurement, what is a spreading coefficient? What are we testing there? On film forming foams like AFFF, AR-AFFF, those should be forming that film over the fuel of the fire to prevent vapor and to suppress that flame. The standard NFPA 25 defines film formation or film forming foam as one having a positive spreading coefficient. So we will do a film formation test with these types of foam. If they form a full film in our Petri dish and the vapors from the cyclohexane fuel are not ignitable, we can assume a greater than 0 positive spreading coefficient inherently. And you may see that on your reports, just simply listed as greater than 0, no ignition, that's great. Because the standard defines that film formation as actually a positive spreading coefficient, if we don't get that full film seal, we will do additional testing on that film or on that foam to measure the surface tension as well as the interfacial tension. So you can see my image here of the tensiometer at work there. It's measuring the surface tension of that foam solution, and then it will measure the interfacial tension as well between the foam solution and cyclohexane. Once we have those values, we're able to calculate the spreading coefficient. As long as it remains positive, above 0, that foam is acceptable and no issues. Should it be a negative number, that would be a failing of the film formation test and would indicate concerns about the efficacy of the foam. Here, like I said, we take these measurements to compare them to known manufacturer specifications whenever possible. If it's always more helpful to know what type of foam you're testing, so you can see how do these measurements come back to what the foam was listed at. Here, per NFPA 25, Chapter 11, once again, specifies when the foam type and brand of foam are known, quality testing shall confirm that the product meets manufacturer specifications. So that's, like I said here, the manufacturer in this case specifies the density, the pH. They give you a range of values here of what is typical and healthy for that foam when it was listed, new, ready to go. Taking these values, we can compare those to our laboratory measurements and see, has the foam degraded? Is there dilution? Like I said, has pH shifted out of balance? Whatever it may be. Viscosity being decreased, concerning, like I said, to the efficacy and the ability to proportion at the nominal rate. So here's an example of one of our Dyne test results here. Just going over how to interpret what these results actually mean for you. Listed out here, as I mentioned, refractive index, density, viscosity, pH, very typical front end testing as we call it here to measure those values. The requirements is what the manufacturer specifies, coming directly from a manufacturer data sheet. And then our measured test values. So as you can see, we will evaluate those physical properties as in spec or out of spec, depending on how they fall in the range. Here, the refractive index specifies from the manufacturer a minimum of 1.36. We measured at 1.3645. That value is in spec and is above the minimum requirement. Again, density falls within the accepted range. Same with viscosity and pH. This is a very healthy looking foam. It looks how the manufacturer intends and how the foam looked when it came off that line, listed, ready to go. The second part of the report here highlights the performance properties. As I mentioned, expansion ratio, 25% drain time, film formation, and spreading coefficient, all listed right there. Here, this is where we get our pass fails for the foam. This is where we're concerned about the actual performance of the foam. I mentioned expansion ratios, typically 5:1 to 10:1. In this case, the minimum is 4.5. We measured at 7. That is a pass. It's acceptable. It's what we would expect to see for this type of product. Same with the 25% drain time. This time is above the minimum. Pass. Excellent. Healthy drain time. Film formation and film seal are listed as you'll see info only here because, like I mentioned earlier, the standard dictates that film formation or film forming foam is actually based on spreading coefficient. So the fail determination does come from this greater than 0 number. In this case, the film was formed within 10 seconds. There was no ignition of the fuel source, so we can assume a greater than 0 spreading coefficient. Should this film have not formed and the product did not perform at that level, we would have a partial film maybe, or no film at all. We can still pass that foam under the spreading coefficient as long as that number is greater than 0. Why test with Dyne? What is the difference with Dyne here? Sample kits are our starting point. Our kits are free. We pay the shipping to you and to get those back to our lab. We run on a 5 business day turnaround here. Everything we're doing is, like I said, within 5 business days there. We do offer rush testing when needed for an additional charge. That's a 24-hour turnaround time. Kits can be ordered online, through email, by phone. However you need to get in touch with us, we can get those kits out to you. Dyne being an independent laboratory, we do not manufacture any foam products, anything like that. We have no vested interest in pass fail. We are simply here to report our findings to you, make sure the customer is well informed and aware of the health of their foam products. Here, I think that is quite a bit. I believe I just ran through quite a bit there. So we are ready to take any questions you may have based on what I have discussed here prior.
Hey, Ben, well, their questions are coming in.
Yeah.
Let's start at the beginning. Let's say you're a customer and you just went through the pre-kits and fast turnaround, they want to work with us. First thing they do, they get the kit. Then what? How are they actually taking a sample? Are they taking a top or bottom? You know, does that depend on how much volume? Like, can you speak to that a little bit? Like, they're out in the field.
Yeah,
How do they do that?
absolutely. Well, it's a top bottom sample is recommended. You would sample that like that comes from the top of your tank, the bottom of your tank. As foam sits in those tanks, it can stratify, layers can form, separation can occur. The foam you may see at the bottom of the tank may not be fully representative of the rest of the foam in that tank. So we recommend our kits, as you saw, the 2-bottle kit right there, 2 bottles here for you. Take a top sample, a bottom sample if you can. That way you can get a more complete picture of the health of the foam in the tank rather than just a single sample point.
How about, so I can just open a test port and just grab right from there, or?
It's recommended that any foam that's been sitting in that test port for a while is probably also not representative of the full health of the system. So it's always recommended to run that system for a little bit, drain out whatever's holding in that standpipe, sludge, dried, dehydrated, whatever it may be. Let that run for a couple minutes, collect that, get rid of that, sample that from a more complete, healthy flow.
Yeah. Have you ever run into like mineral oil? I got 15 tanks that have that mineral oil.
Mineral oil is a frequent problem. Well, I wouldn't say problem, but is a frequent player in our lab, so to speak. It does show up on samples. The mineral oil is suggested by manufacturers to be placed at the top of the foam in the tank there to prevent evaporation and drying of the foam. We don't want to sample necessarily the mineral oil. That isn't going to be representative of the foam itself. So whenever possible, avoid that. Take it from the bottom. Circulate the system if you can. Anything to avoid just a jar full of oil sent.
Yeah, so we got some questions also coming in while we're talking about sampling. Is it each container? Is it, you know, if you got a whole batch of containers, is it, we can treat it as a representative? If I just take, if I have 4 totes, can I take from one tote and count that as it? Or does any NFPA have any guidance on that?
There is no strict explicit instruction on that. If all of your totes, if you have, say, like you said, a group of 4 totes, and it's all the same foam product, these same totes, they're stored in the same similar environment, you can take one sample from that group of totes, consider that to be representative of the group as a whole. If you have different systems or different foam types, you should certainly be sampling those independently to make sure that you are getting an accurate representation of that foam, or different tanks in different locations can certainly have different effects, and the foam can degrade at different rates.
There's been several questions about the types of foam. They put F3, so film forming foam or fluorine free foam if they're talking about.
Yep.
Does it matter? Can we test all types here, or?
Yes, Dyne has the capability and continues to test fluorinated and non-fluorinated foams, AFFF, ARAFFF, SFFF, F3 fluorine-free foam, protein-based foam, high expansion foam. We can test it all, and we will continue to test it until we cannot. So absolutely test the F3 foams. We will continue to test your AFFF foams, but as new synthetic foams hit that market, hit the industry, those are new products. We don't always know necessarily how they're going to behave long term. We just don't have that data yet. So testing of those newer products is almost more important in a way, so we can establish kind of those longitudinal studies and see how does fluorine-free foam continue to work or degrade over time.
Yeah.
I was asking about that actually. The testing methods, are they different for fluorine-free foams versus the non-fluorine?
Largely, no. The testing methods remain by and large the same. It's just about which types of tests are applicable to fluorine-free foams. In this case, the expansion ratio and the drain time measurements that I mentioned as the chief kind of health checkpoints for the foam, those are the same in terms of the testing methods are the same. Requirements differ based on products and manufacturer specification, of course. But that is what gives Dyne the ability to test across all types of foam, is that largely these testing methods are interchangeable, and just it depends what is applicable to a given product.
Well, we're still talking about sampling, kind of on that side of things. One question here about sampling of ARF trucks or storage totes. If we're talking about like airports and things of that nature, they don't fall under NFPA 25. There's another NFPA standard for that. They are allowed to be tested by the airport, the staff there. We could send you some information after the fact to this individual asking about that specifically. But the concept that Ben is talking about still applies of this annual testing. This is a chemical that sits in a tank that can degrade, whether that be dilution or sunlight or even just age. They don't last forever. So I think it still applies if you have a sufficient volume where this is starting to get several years old, even a year old. We are going to have it tested, but that one's a little bit different. I'll have Jenny send you kind of a link to that one after that. Well, we're still in the field, Ben. Again, it says, hey, I'm sampling. What I'm seeing is not completely homogeneous. Is that a problem? Like, what if I have some separation? What if it freezes and unthawed? What are we doing about that?
Yeah, a lack of homogeneity or separation is not necessarily indicative of degradation, so to speak. Like I said, these foam systems can start to settle after however long they've been sitting, depending on the last time they were circulated, sampled, used, serviced, whatever it may be. Dyne will do its best to homogenize that sample during our testing process when we mix it up, and then we will evaluate the performance at that point. It's certainly indicative of obviously some changes. It's not just a static system when the foam is installed, but it's not necessarily an indication of degradation. It is just something to note. Now, if you have a foam system that is in separate layers because it is different foam products, maybe a tank contained 3x6 AR AFFF foam and then was partially refilled with a 3% AFFF foam. Now we have an issue of mixing foam concentrates, different types mixed together. These can lead to unforeseen chemical reactions and greater degradation. So in that term, stratification can be a problem.
Along the same lines, talking about the test results now, if we're just off on the refractive index or a little bit of low pH, is that a sign of degradation?
Really not in necessarily a concerning way. Depending how far off you are, that can be a different problem. If your foam is typically, if the manufacturer specifies a pH range of 6.5 to 7.5, you test it, come in at 8 or 5. That's not too concerning. That's a pretty standard reading. Now, if you came back at a result of 1, your pH was so acidic, that would be concerning. That would mean something else had probably gone wrong. There's some kind of contamination in there. Off-spec high refractive is also usually an indicator of some type of contamination, maybe some rust from the tank or whatever it may be has gotten into that sample. Not necessarily impacting the health of the foam, as long as we're seeing reasonable pass-fail results for expansion and drain time. Samples can be fully out of spec and still perform at those benchmarks to the point that that foam is okay to keep in service.
Here we have someone asking specifically about the spreading coefficient, saying if it's -2 or -3, does it mean that no film will form, or does it still form? It's just delayed. It's just taking longer to get there.
You will get some forming of some kind of film typically. It's tough to say how much though. It could be as much as a 90% film formation, or it could be as little as 1 to 2%. Regardless, the issue that you're going to have is because that film is not a complete film formed around the surface of the fuel, you're still going to be susceptible to reignition or increased fire because that film should be complete. So that's why we're looking for that negative or positive number. We want to make sure that that is going to form a film. I always say some film and some foam is better than nothing, but healthy foam is what we're looking for.
Let's say they got the test results and then they're asking if they do come back bad. Unfortunately, there is a failure. They're asking about, is there any value and is it recommended or allowed to send in another sample? Again, they're wondering, hey, what if the first one essentially is just tainted? it was just sitting in the trim pipe and
Yep.
they're asking about, could they send another sample? They think they got more representative.
Absolutely. And that is, we frequently encounter that here. A failing result can sometimes be the first wake up notice that, oh, maybe something did go wrong with the sampling process. Like Grant mentioned, the trim pipe, if that sample or that system wasn't run for an extended period of time, whatever foam is in there may have dehydrated, may not be fully representative of the health of the foam inside the tank. A failing sample always, we recommend investigation, further investigation. It doesn't mean an automatic replacement, but we should be examining, well, what caused the failure. Sending in another sample, testing it can either confirm or, you know, maybe shed some other light on, okay, well, that second sample was just fine, ready to go. Maybe we just had an issue with our sampling procedure. Ultimately, the acceptance of these results is up to the AHJ, the authority having jurisdiction. Dyne is simply going to provide you the results and evaluate them based on our own metrics. But the acceptance of those results comes from the AHJ.
Yeah, and that kind of gets back, there was another question about, can we collect it from a remote connection or should it be from the tank? Can you speak again to the taking a representative sample?
Yeah, the keyword there is representative. You want to get that foam, that sample should be as close to the foam, the whole foam system itself, as you can get it. You want it to be representative because you want to truly know the health of the foam inside that tank. I would recommend sampling directly from that tank whenever possible. I would honestly recommend sampling both and checking both because, you know, as that foam travels, maybe there's a breakdown somewhere along that line in that system, contamination somewhere outside of the main tank or that remote test connection. More sampling is always better. It gives you a more complete picture of the health of the system at large.
And they were asking, how much sample do you need to provide? How many liters?
Yep. Our standard and FDA testing bottles are 250 milliliters. We do ask that whenever possible, you fill that to the full 250 milliliter fill line. Just gives us the right amount of foam to work with and verify all of our testing. We do provide the 2-bottle or the 4-bottle kit. So if we can get a top bottom 250 mil sample each, that would be fantastic and gives, like I said, a much clearer picture of the full health of the system. Any sample you can get is a good sample as long as there's enough to test, but a healthy, fully representative 250 milliliter sample is ideal.
How about we talked about, we're still testing AFFF. Some people are switching out to fluorine free. We have an individual here asking specifically, are we able to tell the difference there? Do we do any fluorine testing to help them as they switch out and try to identify, did they clean the system? They specifically bring up, hey, there's contamination that can occur when these systems are being changed out. Do we do anything like that?
Dyne does not do any of the fluorine testing here in our laboratory. That's not something we're able to assist with directly. We don't have necessarily any ways either of in the laboratory testing just a mysterious foam sample and determining which type of foam it is. We cannot identify AFFF versus SFFF versus ARAFFF without some kind of indication from the sampler themselves.
Are those tests available though, if they need to go get them?
There are, yes, yep. Fluorine testing is available at other laboratories and can certainly be provided, but it's just not something we offer at this time.
Yeah. What is recommended? So again, we're getting back to, we did have a failure. All of a sudden we have all this foam we said is bad. What's the recommended disposal? And they specifically asked, could we use it in drills?
I can only speak so much to the laboratory side of things. Unfortunately, my expertise is entirely here in the lab versus out in the field. Failed foam, disposal of foams can be a difficult topic in terms of you want to make sure you're disposing of that in a fully compliant and healthy way. If you are replacing that foam entirely and you still have a huge stock of it on hand and you want to use it for drills, certainly an option, but just know that discharging that foam will lead to further disposal costs, especially if it's fluorinated AFFF foam. That's going to be harder to dispose of, and if you're using that, make sure it is fully contained for those testing.
Yeah, I think in today's climate, the use of AFFF for training is probably pretty frowned upon. Yeah, just follow your local regulations on what's required if you're gonna ever flow any foam. There's another one here, kind of more on the legal side as well, about who's responsible ultimately for conducting this test. Now, I know NFPA 25 is written ultimately for the building owner, but typically a contractor, they're gonna hire, right? It's the building owner's responsibility, but a contractor would be hired to do this work. It has to be in their scope though, right? Whatever contractor they hire,
Mhm.
it should be inside of their scope of testing. Do you have any more words to say that who's actually doing the testing?
Like you said, ultimately, the standard puts the onus of the testing and all of that compliance on the building owner themselves. Frequently, that is then sourced out to a fire protection specialist, contracting company, whoever it may be. They are responsible then for pulling that sample and getting it over to us. We do our end of the testing, gets the results back to whoever it is that pulled that sample, and they can work from there with the building owner, whoever it may be, to address any issues that may have come up.
And then we'll have a couple of rapid fire here, not in any particular order now, but this individual is talking about proportioning in the field, and they use a conductivity meter. Can you start by just describing the proportioning test and how we can help and whether or not we use conductivity or refractometer?
Yeah. Our testing in the laboratory does not use the conductivity method, or we are using a refractometer to measure the refractive index, a benchtop refractometer. If you are doing a proportioning test with us, you would ideally send us, you will need to provide a concentrate sample of the foam concentrate used to make that solution, as well as a sample of the solution that you made on site with the proportioner. Here in the lab, if you're able to, the water, sample of the water that you use to make that solution is also greatly appreciated and will create a more accurate result. But in the lab, we will take that concentrate sample that was used to make your solution at the proportioner. We will mix up exact specific proportion samples here and create a calibration curve where we can then plot refractive index of all samples to determine the estimated concentration percentage.
Yeah, right on. That's what this individual was asking about too. And manufacturers don't provide reference values like conductivity at this percent. And it sounds like he's doing it right. He's preparing some standard mixtures of water concentrate and comparing it. Conductivity, again, we don't do that here in the lab. It works out in the field. Typically, your field refractometers aren't as accurate. They're not as accurate as what we have, to where conductivity starts to become more reasonable out in the field for you. Just be careful if your water, that it ain't going to work in seawater, right? There gets to be a certain point where conductivity, that's its kind of struggle on those more conductive samples. A few other just random ones as we're going here. Again, there was about sampling point. They may have missed the earlier thought.
Yeah, top, middle, bottom. If you can get all three, that's ideal. It'll obviously give you the clearer picture. Top, bottom is the next best, because as mentioned before, that foam can stratify in the system. You can find some separation, lack of homogeneity. Ultimately, a bottom sample is better than no testing at all. But whenever possible, a top, middle, or bottom, all three together is ideal.
We got some questions here about shipping of samples. One is, do we ship outside the United States? Can they get kits outside the United States?
Yes, we do. We do ship internationally there. Kits are available outside of the continental United States.
Yeah.
Free shipping, we do cover within the continental United States. Outside of that, we do charge for the shipping, but the kits are free, with the exception of our sprinkler testing. So
we have some questions here too regarding those new products, those SFFs. Have you seen any differences? Again, someone's kind of commenting on the viscous nature of them. Have you seen anything else or anything we should be aware of?
We are, obviously, like I mentioned earlier, we are still kind of in that fact finding time with these new samples as they come into us for testing. We are still establishing our kind of baselines for that. We do typically tend to see more viscous samples of the synthetics compared to the SFFF foams compared to ARAFFF foams. We just don't have enough data at this time to see how that's going to impact the longevity of the foam in terms of, is this viscosity typical, and is the foam healthy year after year with this viscosity, or is this indicative of breakdown, of dehydration of the foam? Is it going to affect the ability to proportion next year or the year after that? We are still kind of gathering that information as we can.
Similar along the same line, life expectancy.
Yep.
They even bring up, hey, AFFF was 20-25 years. Do you have any idea that SFFF, this new product, what it's going to be?
Difficult to say. The benefit of that AFFF, of that fluorinated foam, is its dating power. Those forever chemicals, the PFAS, is so good at creating that stable bond and making sure that it is still viable 25 years after install or purchase. I have seen personally some synthetic products coming to market here where they come with a shelf life printed on their manufacturer data sheet, indicating, this foam is only good for so long. It really is at this point kind of product dependent, manufacturer dependent. We're all kind of figuring that out together at the same time right now.
How about they specifically asked, like they have an AFFF that's 25 plus years old,
Mhm.
but it passed the testing. Can that continue to be used, or does NFPA put a maximum?
That is still acceptable as long as it is passing your annual quality testing. It is still acceptable for use in the system, and you can continue to use that. Should it fail the next year around, then you would want to do some further investigation and possibly looking into a replacement.
And what if now they're getting specific? You were talking about sampling points.
Mhm.
What if the top passes, but the bottom fails, or vice versa? Let's say the top's a little diluted, that fails, but the bottom looks good, not diluted. Is it considered an overall failure? What do they need to do? Can you speak to that? If the top fails, but the
Yeah.
bottom
Again, ultimately, in terms of overall pass fail, in that case, is going to fall to the authority having jurisdiction, the AHJ, who's interpreting these results. If you say, like Grant said, maybe the top is a little more diluted and that fails the testing versus the bottom, I would personally recommend cycling that system, agitating that system, mixing it up as much as you can, and resampling. Trying to take a more composite sample will give you a clearer picture of, is this a widespread throughout the foam system problem, or is this just a bad sample from the top or a bad sample from the bottom? Whenever possible, you get those results. Testing against kind of either confirm or deny those results can really help you get a clearer picture of what's going on inside your tank.
Thank you for that. The individual asking about bladder tank levels and sight glasses not being installed. That's probably a little bit out of our expertise. I'd recommend either tank manufacturer specifically or even the foam manufacturer. That foam should be listed for specific products and with products. They'd probably be able to better help you with that, unfortunately. We can, if you need help getting in contact with someone, certainly reach out and we can help you with that. Our contact information's on the screen. We still got some more though, and I think we're doing okay on time. We can keep going a bit.
Yeah, absolutely.
Here's an individual asking about the sample when done with it. What do we do with it? And can they get it back? He's asking, can I get it back to put it back in the system if it passes?
I wouldn't recommend necessarily reinstalling the sample back into the system. And ultimately, it's going to be pretty much a drop in the bucket at that point. The 250 milliliter sample that you've sent to Dyne for testing, after we've tested it, you may not get even 100 mils back once the testing has been completed. I would not recommend reinstalling that or adding that back to the system. Those samples are held in-house here for 30 days after reports are generated, just in case further testing is needed, but then they are disposed of according to guidelines. So really, once you pull that sample, I would anticipate not seeing that sample again and just kind of budgeting that in.
How about someone here asking about, again, the new fluorine-free foams? Again, we're calling them SFFF and NFPA. Some people have heard of them as F3. But those new fluorine-free products, they've noticed they become more viscous, extremely high over time, or when in contact they get hydrated or contaminated water. Are you seeing that, or is that just them noticing?
That's actually something we are looking into here in the laboratory, actually actively at this time. We are examining the effects of water on the polymers in synthetic foams. If there is a hidden gum polymer that is reacting to that water, it can increase the viscosity and cause some issues, obviously with proportioning. Too thick to run through the system won't give you an accurate proportion. So stay tuned on that. We are hoping to generate some information, some data, some studies, and be able to share that information with the industry.
Ah, very good. So yeah, you are seeing that too.
Yes, that is something that we've noticed. It's been written about in some technical articles, and we would like to see kind of application, real world results in our lab.
Here's an individual asking about shell water specifically. So we're talking a bladder tank and the water side. Can we take a sample of that and we can determine whether or not there's foam contamination in it, whether the bladder is compromised? Is that something you can do?
Absolutely. Something we see pretty frequently. Shell water samples coming through. It's always, I work in a testing laboratory. I'm always going to be an advocate for testing. I think it gives you such a good idea of what's going on in that system that, like I said at the beginning, you can't necessarily see visually. The shell water testing there, it's always great to be able to take that and compare it to the concentrate, and we can provide an estimated concentration of foam in that water sample. If there's a high concentration of foam, if we are seeing a lot of foam in the water itself, 50% or higher, I mean, I've seen them up to 80%. That typically indicates a tear in the bladder and can cause cross flow of foam to water prior to proportioning, which means you're going to have dilution of the concentrate itself. You won't be proportioning at that correct rate, and you will see decreased efficacy. So always, if possible, a shell water sample is a great thing to test. It's an easy test to perform. It's if you're in for the penny, you're in for the pound. I always recommend it to see the health of the system.
And someone's asking to clarify, that's not required though, it's just
Correct.
recommended.
Correct.
Shell water is not required.
Shell water is not a required test. It is just recommended to give you a better picture.
And if that bladder is here, is the foam getting out? Automatically contaminating the?
It's very likely, yeah. If there's a tear in that bladder, at some point that foam is going to meld with the water. Depending on the volume, the size of the tank, and the degree of the tear, it may be minimal. It may be contained to one small area of that foam or concentrate, but a more significant tear can lead to greater problems and increased dilution.
Someone's asking specifically about, again, we're back to those new foams, which makes sense. They're new. They want to know about them. Have we observed any concerning failure rates? Is it looking like AFFF would at this point in its life? Anything there other than maybe the hydration you talked about?
Yeah.
Concerning. We're looking into that.
The hydration has been an issue. We do see some samples. They come in, they pass the blizzard test where we're able to fully invert the sample jar, and not a single drop falls out. When they get to be that gummy, they sometimes have we have difficulty proportioning them at the correct rate, mixing those to make a homogeneous solution. I would imagine in the field, you're going to be seeing similar situations, and it's going to affect your ability to proportion. That's typically where we see failures for the synthetics coming in, is as they thicken up, maybe they're not mixing as well, they're not expanding properly, and then they're not meeting those benchmark requirements. So we have seen failed samples already.
Yeah, very good. I'm not seeing any more questions flying through here. We could probably wrap it up pretty soon here. Again, Ben's contact information, just ben.quick@nfpaglobal.com. The general line Dyne is on there. You can go on that email. You can call to get kits. We'll probably wrap it up here, Jenny, if you want to go, and I'll just monitor if there's any questions as you wrap up.
That is all from me.
A little spiel at the end.
Yep, I will hand it right back off to you, Jenny. You are ready to go.
Well, thanks everybody. You asked some great questions. We had a great number of attendees on the line. Thanks to Ben for stepping in and giving a webinar here at Dyne, and for Grant on the assist. Team effort. So thanks everyone. We are going to be sending a survey and appreciate your feedback on any future topics you'd like us to cover. We'll also send a link to the recording of this webinar. Our next webinar is scheduled on Wednesday, June 17th. It's going to be on our new services that I announced at the beginning of the webinar. If you missed that, it is corrosion and mix, diesel fuel, and water mist nozzle testing that we're going to be coming out with this year. So stay tuned for more information on that. There will be a link in the email to register for that. So that's probably one you don't want to miss if you're interested in any of those types of testing or need that as part of your portfolio. And always watch the Dyne website, our LinkedIn or Facebook pages, and our monthly newsletter for more information. Thanks again for joining us. And from me, we'll see you next time.